Yeah, welcome to the introduction session of the thermodynamics one. In the previous session of the classes, we have learned about the what is engineering, mechanical engineering, who was the contributors and all. Let us move on to in detail more about. Uh, Suppose, as just before I told you in the previous classes, like there are spontaneous processes that occur in nature. There are some certain processes which cause to occur in nature of their own purpose, but all these physical properties are not at a random or occur in any arbitrary way. These are all a rhythm of all the physical processes which occur in nature. Uh, for example, let me put some examples to make you clear understanding about this. The water which falls from the higher elevation to lower elevation, which actually takes place based on the natural law, which doesn't happen naturally. In which, yeah, if you want to do it, there is some additional systems to make it to flow, as the heat flows from higher temperature to lower temperature, but not the reverse one. There are many other processes which we occur, cause to occur. They do not occur in the reverse way. For example, conversion of mechanical energy into heat or maybe intermolecular energy is possible. Let me take for another example to make you clear understand. For example, if we stop a moving body, the body becomes hot. If you take a duster and if you're rubbing over here, if you stop it, then what happens? It becomes hot. That is due to the friction which has been generated over there. Thus the mechanical energy is actually converted into your intermolecular energy. But thus the reverse doesn't happen, right? But the other end, there are many other processes which can be caused to occur in both the directions. For example, we can heat a body, we can cool a body, we can expand a gas, we can compress a gas. But these cases also we see there is so change in external surrounding when you cause the process to occur in both the forward and the reverse direction. Now, the subject of the thermodynamics is basically based on the laws of the nature which has been found by observation of a common experience. That means if you consider the thermodynamics as a table, which I told you, there are four legs. These four legs is nothing but the laws of the nature. These which are sometimes observed in the nature by your day-to-day experience. For example, we grow old. We do not grow young. The hair grows, which is gray, not black. These are all parts of the thermodynamics itself. These are all the direction laws. The second law of thermodynamics gives you a direction in which way to travel. If it violates the second law, it doesn't take place in the nature at all. So these are laid by the legs in the basic frame of your thermodynamics itself, from the laws of the nature by the observation or maybe our common experience. At the same time, by experimental observation in the laboratory, which frame the basic works of your thermodynamics. Let's say if you move on in detail in the next slide. I go on to the next slide. Yeah, those are the applications and all. It is, there is a pure substance. Pure substance is nothing but which is already learned in your schooling level, where the properties of the substance, this naturally depends upon your behavior of the particle. For example, there is a pressure of the gas in a container is a result of the momentum transfer between the molecules and the walls of the container. Let me take an example to make you to clear understanding. Uh, Let me take a pot and pour some water into the pot and heat it. As when the temperature is rising, if naturally if you observe by your naked eye, can you tell me the exact temperature of that? Oh, it is very difficult because some things you can actually based on the observation you can say it, and some things you cannot. So in that, if I want to know the exact temperature, place the thermometer and know the temperature of that. And suppose if I want to know the pressure in that particular one, then what is I need to do? Like I have to place a pressure gauge and then note down the pressure. Similarly, when you are trying to learn something in a thermodynamics, there are two things. One is statical and classical thermodynamics. So most of the things which you are learning is a statical thermodynamics itself. And let me put in a different, simple way to make you understand. Nothing but we say it as a two study, which is macroscopic study and microscopic study. Macroscopic study is nothing but which we study in statical average data. Microscopic in the sense which we learn in detail one. Okay. uh, Let me go on to the other applications. These applications which is already I've given you in the other class, uh, of your introduction to class. and also I've given you all these examples to make you to understand. This is about the introduction class of your basic understanding. If you further move and if let me put in your more in detail, if you say biological and all those things which is already I've told you, uh, right now the major trend is happening in a biological field itself. This thermodynamics is helping out as the COVID situation which is taking place. I already told you there is a bits planning who has been invented the face mask where he can give you actual moisture which is generally present, how much oxygen content is present, and whether the virus is present, and all those details information is given based on the IoT platform and the artificial intelligence. If you include with all those things, you can do the wonders. That's the case. I'm stressing more to understand the basic importance of the subject, which may help you in your future. Mm. So try to learn the subject and gain by knowing more examples. Which I told you in automobiles is a major sector, which is the applications of your thermodynamics itself. Let me put an example for you to understand. Consider a few of the energy which is actually flowing in the car. How does the energy comes in? As a gasoline which is generally present in a tank, which is allowed to flow from your tank onto your what do you call this engine from the manifold, which you have the carburation and the fuel injection based on your either it is a gasoline, either it may be a diesel. And once it has been entered into the manifold, then the combustion takes place based on the strokes which you have. All those strokes I will let you know later when you move on to the unit number 5 and the basic cycles when you are learning. So this gasoline which is stored in the tank until its energy is needed to move the vehicle from one place to another, then the gasoline is pumped from the tank to the engine. In the engine is fuel is burned, and some of the released chemical energy is being converted into useful mechanical power to propel the car. These mechanical power is also extracted to drive the water pump, which is used in the engine cooling system, the alternative to provide electrical power from the CD player, the lights, cooling fan, motor, fuel pump, all the air conditioning system. So these basics applications all comes under from the thermodynamics itself. And the steam power plant which I told you the best example, and cooling system which is present in a car. And if you take the what do you call refrigerator, or maybe the air conditioning system, all this comes under the basic examples of your thermodynamics applications itself. So please guys pay attention of this particular subject. This is very important subject. If you are clear with the subject, the next coming subjects will be very simple and easy to predict, or you may have your future better by understanding. So thank you for listening patiently all these videos. I'll catch you with the next video with the basics of your system surroundings and all. Already I've gone through the basic one in the regular class. In detail video, I'll take another video by recorded one. Thank you.